The direct application of animal manure supplies the agricultural soil with valuable organic matter and essential nutrients like phosphorus, nitrogen, and potassium. These nutrients help to meet the crop requirements for growth and maintain soil fertility. However, in regions with intensive livestock production, land application is not always an option because of the already high nutrient content in the soil and because of strict regulations on the amount of manure per hectare in order to avoid environmental pollution. In these regions, manure management is becoming extremely challenging for the farmers.
So we are facing a lot of problems with the manure because we have animals and we have not enough farmland to apply this manure on the farmland. So therefore the only way now is to transport this manure into other regions. That makes a lot of costs, a lot of time, and that's not really a good solution for the future. So we have to find out better solutions to handle this manure.
This manure tourism cannot be seen as a permanent solution for this problem. Therefore, the development of a cost-effective and environmentally friendly technology for the management of manure is crucial to maintain the European agriculture industry on business and minimize pollution. In the EU-funded project BioEcoSIM, led by Fraunhofer IGB, 14 partners from 4 European countries from research and industry have developed, built, and demonstrated an innovative technology to convert livestock manure into organic soil improvers and mineral fertilizers.
We have developed a totally new approach to valorize manure. Now we are converting manure into fertilizers and soil improvers. So what was before a problem, a waste, now it is a marketable product.
The overall process uses energy-efficient technologies and works on the principle of circular economy. The technology consists of various modules that can be implemented according to the specific needs of the different regions with intensive animal husbandry in Europe. One module dissolves the phosphorus completely and separates the manure into a solid and a liquid phase. The second module dries and pyrolyzes the solid fraction into a soil improver material using an energy-efficient technology based on a superheated steam thermal process. In the third module, phosphorus is recovered as mineral phosphate fertilizers from the liquid fraction. Nitrogen is recovered then in a fourth module as ammonium mineral fertilizers. What remains is water that now contains only traces of phosphorus and nitrogen, but which is rich in potassium and ideal for irrigation purposes. The technology prototype is capable of processing 50 kg of raw manure per hour into 1 kg of mineral fertilizers and 900 g of organic soil improvers.
Together with our partners, we built this prototype. The process is robust, efficient, and affordable. This process will help the farmers by solving the challenges in manure management.
Researchers from the University of Hohenheim in Germany and Itagra in Spain have performed extensive studies at laboratory level, in greenhouses and in the field, with the mineral fertilizers and organic soil conditioners recovered from livestock manure. These products have a very high quality and can be used as readily available fertilizers and humus-forming substrates in agriculture.
We were able to demonstrate that the BioEcoSIM products are excellent fertilizers in 2 climatic zones in Europe. Today we are applying the phosphate salt to plots for maize, and the winter wheat you can see over there was already treated with the phosphate salt last autumn before sowing. The results we've obtained so far from our studies showed that the biomass yield and the nutrient uptake of crops like cereals, maize or sunflower were absolutely comparable to those of commercial mineral fertilizer. And depending on the soil type, the BioEcoSIM products performed even better in some experiments. And this outcome confirms the great market potential of our products.
The BioEcoSIM single products are dried, easy to handle, and transport. They can also be mixed together to match the nutritional requirements of any crop.
We are using the pea salts from the BioEcoSIM project to produce fertilizer sticks. They are looking like that when they are finished. And in trials we found out that the fertilizer sticks do not only improve the soil, but they also improve the growth of the plants. And for the future we can imagine to work with these granulates as well. We can add them to potting soils as well as to ready-to-use fertilizers.
And what are the demands of the farmers for the product?
The professional farmer will judge the market value of each product he can buy as follows. He will look to the quality of the product. Are all nutrients available that he needs for the plant, and are they available at the right moment and the right time? He will judge if the product is easy to use. Can he use it with his machinery that he is having already in his possession? He will look to if the product will meet all legal requirements of the state or of his city. And he will, last but not least, he will look to the price. Does this product compete with all other products he can buy in the marketplace?
In the future, this design fertilizer will prevent the over-fertilization of the soil and will save on synthetic fertilizers. The production of synthetic nitrogen fertilizers requires large quantities of energy. On the other hand, synthetic phosphate fertilizers are obtained from raw phosphate using elaborate processes. Moreover, the mass of the dewatered and processed products make up only about 4% of the original volume of livestock manure. The number of round trips necessary to transport the manure would be radically reduced. All these factors will have a drastically positive effect on the sustainability of the process. Ley has evaluated the sustainability of the whole process using an approach based on ISO 14040 and 14044, comparing the BioEcoSIM process with state-of-the-art technologies.
The BioEcoSIM process can reduce the cost of manure processing from about 25 euros per ton manure now, in the case of long-distance transport, to about roughly half. Environmental benefits come from the reduction of over-fertilization and from the avoidance of production and use of synthetic fertilizers. Further, social benefits of the BioEcoSIM process come from the reduction of transport and odor.
Detailed cost-benefit analysis of the BioEcoSIM process have been calculated. The plant has not yet been able to pay for itself out of the sale of the products alone. But if we consider that the farmers in regions with intensive livestock production are paying at the moment up to 25 euros to dispose a cubic meter of pig manure, BioEcoSIM can offer a huge saving potential. BioEcoSIM's technological solution will mitigate the current environmental and economic challenges of manure surplus in regions with high livestock densities. This will benefit livestock farmers by generating savings from manure disposal. Crop farmers will benefit from reduced consumption of synthetic fertilizers, reducing their dependency on non-renewable sources and fertilizer imports. Through the implementation of the results on a trans-regional basis by small agricultural entrepreneurs, new economic opportunities will be generated, and the move towards a more resource-efficient and circular economy can be facilitated. The consortium aims to construct a full-scale prototype ready for series production for the following market introduction.